Okay, you are welcome to our online lectures. Today we are going to take a look at pharmaceutical calculations. Pharmaceutical calculations. Give me another marker. Pharmaceutical calculations. Pharmaceutical calculations. By a way of introduction, what do you understand by pharmaceutical calculations? Two words are involved here: pharmaceutical calculations. From a layman understand, you can see calculations in pharmacy. But let me introduce the course. Pharmaceutical calculation is one of the branches or a course of study, or simply a study of the use or the application of basic mathematical principles in the compounding or formulation and dispensing of drugs and other pharmaceuticals. So in summary, pharmaceutical calculation is simply use of basic mathematical principles. When you hear pharmaceutical calculations, maybe your mind will just, hey, pharmaceutical, hey, one big calculation. No, it's just this normal basic principle. If you have a basic understanding of mathematics, the basic principles used in mathematics of addition, subtraction, ratio, division, percentage, fractions, these are the basic principles. Somebody that did mathematics should know. With this basic principle, you apply it in what? In the formulation, compounding, and dispensing of what? Drugs and other what? Pharmaceuticals. That's what pharmaceutical calculation is all about. Now, in our previous lecture, that is already online on our YouTube, SUSEM Limited. If you go there, we already have an introduction of what pharmaceutical calculation is all about. Then there also we discussed a very important topic. The first thing there is numbers and numerals, where we define numbers, define numerals. Go check it up. You understand? You have a basic understanding of what numbers are and what numerals are, and the difference between numbers and numerals. Sometimes people interchange them. A number is that idea you have in mind. A number is that idea, maybe say 4. That idea you conceive in your mind, 4, is a number. It's abstract. That idea, that abstract abstract number you have in your mind, you want to you used in your conceive in your mind to determine quantity of materials or substance, is number. But numerals are what you use to represent that number. For example, now 1, 2, you have 1, I. Are you there? If you look at these two things now, this is 1, this is 2. This is also 1. This is also what? 2. The number in your mind is 1. For this one now, the number is in your mind is just 1. For 2, number is in your mind this 1 into 2. This 1 plus another 1, 2. Is the number you have in your mind. But look at how these numbers are now represented using different words. Forms, in different forms. These forms in which they are represented is what we call what? Numerals. That's why here now, what type of numeral is this? This is what? Arabic what? numerals. And this is what? Roman what? Numerals. So look up that video, that lecture on numbers and numerals on YouTube. You understand it better. Let us not waste time on it. Let's go back. Let's go to what we have today. Today we are continuing in pharmaceutical calculation. Today we are going into what? Another basic principle. We are going into what? Fractions. We are going into what? Fractions. Fractions and what? Percentages. Fractions and what? Percentages. Fractions and what? Percentages. You've been talking about fraction from primary school to this level. Fraction. But now in pharmacy, we are going to apply fraction in pharmacy. Not just calculating 1/2 plus 2/4. We are now going to apply it in what? Pharmacy. With that basic principle on fraction, we will apply it in pharmacy. But before we can do that, we are going to say one or two things about fraction. About fraction. Now, fraction. When you hear fraction is talking about a part of a whole. A part of a what? A whole. Fraction is a part of a what? Whole. For example, now, look at this cycle. Look at this cycle. This is a whole. Excuse me. Whatever. Sorry about that. So now this is a whole. Are you there? Yes. Now take a very good look at this. It's a whole. Now, if you divide this whole now, it's a whole, right? Yes. If you divide by whole, I mean whole, not whole. If you divide this into two now, this part is a fraction of this whole. This shaded part now is a fraction of this. So if you want to represent this shaded part now in a fraction, as a fraction, what will it be? 1 over what? 2. Good. So this is what fraction is all about. You know the principles of addition, subtraction. We are not going into that now. We are going to into the application in pharmacy. Now, but let me just say one or two things. In fraction, we have what we call common fraction. Common fraction and what? We have decimal what? Fraction. Are you there? We have decimal fraction and common fraction. Common fraction and normal fraction, 1 over 2, 2 over 3. Are you there? 5 over 7, all this, 1 over 2 over 4. These are common fractions. We also have decimal fraction, the one that has what? Decimal point. You can convert this common fraction to decimal fraction. If 1 divided by 2, it will give you what now? 0. What? 0.5. I mean, now see that it's the same thing. This half and 0.5 are the same thing, but they're represented in two different types of fraction. This one, 1 over 2, is common fraction. While 0.5 is what? Decimal what? Fraction. The same way, all these ones can be converted to what? Decimal fraction. A decimal fraction has a what? Decimal what? Points. Now, this is what we mean by common fraction and what? Decimal what? Fraction. But under common fraction, that's where you start having other types of fraction. We have your proper fraction. Proper fraction is a fraction whereby the Of course, in a fraction, you should know that the one at the top is called what? Numerator, right? The one below is called what? And this line is called what? The fractional what? Line or whatever. Are you there? Now, in a fraction like this, where the numerator is less than the what? Denominator, such fraction is known as what? Proper what? Fraction. Sometimes the denominator may be the numerator may be larger than the what? The denominator. Are you there? The numerator may be larger than the denominator, as in 4 over what? 3. This fraction is called what? Improper fraction. Sometimes you may have another one we call what? Mixed fraction. Mixed what? Fraction. In a mixed fraction, you can have something like 2 whole number, 1 over 2. This is a mixed fraction because it has a whole number and a what? And a what? A whole number and a proper fraction. Sometimes this improper fraction are normally, maybe after calculation, are normally represented or converted back to what? Mixed fraction. Because you don't leave the answer like this in an improper fraction. You put it in what? Mixed fraction. I'm just trying to, refresh our memory on what we've known all from primary school till now about fractions and decimals. Fractions and decimals and what? Under fraction now we have this, right? Common fraction and what? Decimal fraction. Now, percentage is no longer a new term. But before I'll continue, I want to talk about something. Our reference book for today's topic is what? Pharmaceutical Calculations, 14th edition, by what? Howard C. Ansel. This is our reference book for today. Most of the calculations we'll be solving here will come from here. Pharmaceutical Calculations by Howard C. Ansel, 14th edition. Now, let's go. At this juncture now, with this background knowledge and refreshing of our memory, so let us now go down to picking some practical scenario and solve questions on what? Fractions. After that, we enter what? Percentage, and also solve questions on what? Percentage. I don't know if you have any question to ask. If you have any question, ask. If you don't have, let us fire on. So we should fire on?
Yes, sir.
All right, let's go. Or before, let me run down percentages before we can continue. After talking about percentages, we now go into proper calculations. We now go into what? Calculations, proper, using practical scenario in pharmacy. Now, you'll be hearing about percentage. Can I clean? Do I clean?
Yes.
All right. You'll be hearing about percentage. What is percentage? Now, look at it. Let's break down the word. Let me get marker. Let's break down the word. Percent. Let's break down this word at this junction. Are you there? Per mean you can use it for each. Per for each. Cent. That means percent means for each what? Cent. For each what? Cent. And in mathematics, whenever you see cent, what comes to your mind? What comes to your mind? What comes to your mind is what? 100. True or false? So percent is what? Per 100. Right? Percent is what? Per what? 100. So whenever you hear percent, it's talking about what? Per 100. Per 100. For each 100. In each 100 as the case may be. Now let us go down again. And it's represented with the symbol this, right? True or false?
True.
Now let's go. Let's assume now that you have something like this. You have let's say 50%. What does 50% mean? It means 50 per 100. Three of us. 50 per what?
100.
Per what?
100.
100. Which is certain as what? 50 over what?
100.
100. Have you now seen that this thing has been represented as a what? Fraction now. Can you see some can you notice something here now? 50%. I said that percent is talking about what? Per 100. Now we have 50%. So here now, putting it here, you now have 50 per what? 100. So which is certain as what? 50 over what? 100. Which is what? 0.5. Have you now seen that percentage can be converted to what? Converted to what? Common fraction. And from common fraction to what? Decimal fraction. It shock you? You see the relationship now.
Yes.
You can start from percentage, convert it to what? You can convert a number from percentage to what? Common fraction. From common fraction to what? Decimal what? Fraction. You can also start from here, convert back to here, and back to here. Apart from the 50%, let us do something else. Something like let's assume we have 200 people. 200 people are here. Then 50 people, or let's say 50 of them. Let me say 10 of them are black. 190 are what? White. We have total number of what? 20 what?
200.
People. 200 people. Sorry. Then 10 are what?
Black.
190 are what?
White.
White. Now, what is the percentage of the black people? So the first thing to do is to do what? How many black people are there?
10.
10. We say 10 over total is what?
200.
200. Before now, you just go through a rush, and do times 100%. Right? So why? How did it come about? You don't know. You just, but they told you that it's just 10 over 200 times 100. You get the answer. But let me tell you how it came about. How it came about. Now, here, if we saw it using what we were taught, you have that 200 divide this. This divide this, right? It will give me what? This 0 cancels this 0, right? 0 cancel 1 0 here. 2 divide 10 is what? 5%, right?
Yes.
Now let's see. Let's break it down so that you see exactly why it's 5%. Now let's see. We have 10 people, right?
Yes.
Over what?
200.
Remember, this is 10 per 200. But they want to know the 10 per 100 in 100. What do we do? For us to get it in 100, what are we going to do now?
We divide by 2.
We divide both the numerator.
And the denominator.
That brings me to something I want to talk about fraction. There's something, let me refresh your memory. We have what is called equivalent fraction. Equivalent what? Fraction. Don't worry, I will use this to show you what is equivalent fraction. 10 over 200. Let's find this in 100. In 100, it will give us what? We divide both sides by what?
By 2.
Upper and the numerator and the denominator by what?
2.
2. It will give us what? 5 over what?
100.
Yeah, let me use this to talk about equivalent fraction. Are you aware that 10 over 200 is the same thing with 5 over 100? Are you aware? They are equivalent fractions. Equivalent fractions are fractions. You can, if you divide a fraction the numerator of a fraction and the denominator of a fraction by the same number, it will give you equivalent fraction. Or if you multiply it by the same number, not that you go and divide the numerator by 3 and divide this one by 2, it cannot give you equivalent fraction. But if you divide it by the same number, like say if you divide numerator by 10, let's say you decide to divide by 10, it's also certain as 10 divided by 10 is what?
1.
Over what? 200 divided by 10 is what? 20 now. Must use the calculator. 200 divided by 10 is what? 20. Just cancel 1 0. Are you aware that these 3 fractions are the same thing? Punch your calculator. All of them will give you what? The same thing. Punch your calculator. All of them will give you the same thing. They will all give you 0.05. Punch it. That's why they have the same value. That's why even though the numbers there are the same, but they have the same ratio. The numerator and the denominator are the same thing, the same ratio. So if you check it now, it will give you the same thing. All 3 of them will give you the same thing.
Yes, it's the same thing.
They are equivalent to what? So if you want to get an equivalent fraction
You use the same
of a fraction, either you multiply the numerator and the denominator of the fraction by the same number, or you divide them, both the numerator and the denominator, by the same what? Number. You get what? Equivalent of that fraction. So now let me continue. You now understand what equivalent fraction. So let's continue. Remember, we are here. For us to get it in per 100, we divide both upper and the numerator and the denominator by what? 2. We now have 5 over what? 100. This 5 of 100, let's put it in word. What is it?
It will be 5%.
Don't rush to the answer now. Come step by step. 5 per what?
5 per 100.
Good. 5 per what?
100.
5 per 100. Remember, I told you that per 100 it's certain as what? Per what? Percent. So this is certain as what? 5 per what? Percent. Which is, put it in symbol now. 5. You should come here. You shouldn't come after. You should come before. Is it before or after?
You should have.
5 what? Percent. All right. Have you not seen it now? But you didn't hear 10 over 20 times 100%. Wow, answer. But have you not seen how it came about? This is basic understanding of the word percent. So with this now, okay, let's calculate for the whites. White people are how many in there?
190.
190. So in all, 190 per 200, see? Yeah. 190 per what?
200.
But we are not looking for it per 200. We are looking for it in per
100.
So we look for equivalent fraction of this that will give us 100 as the what? Denominator. True or false?
True.
So, and the only thing that can make this to happen is to divide the 200 by what? 2. So for you to get equivalent fraction, you divide both the denominator and numerator by the same 2. So if you divide the numerator by 2, it will give you what?
95.
190 divided by 2 is what? 95. All over what? Divide the denominator by 2, it will give you what?
100.
100. So put this in word is what?
5 per 100. 950 per 100. 95 per 100.
90 what? 5 per what?
100.
Which is as what?
95%.
Per what? Percent. Is certain as what?
95%.
In symbol form. So 190 of 190. The percentage of the white people here is what? 95 what? Percent. Does it make sense?
Yeah.
So with this basic understanding, let us go into calculation, application of these fractions and the percentage in pharmaceutical what? Calculations. Then we'll start talking about drugs. We are going directly to drugs. Its application in the drug. Let me get our reference book. Remember, our reference book for today is Pharmaceutical Calculations by 14th edition by Howard C. Ansel. It's a very good book on pharmaceutical calculation. Now let us the calculations we are going to do today. We will take it from there. They have some real life scenario here that will help us to appreciate the applications of fractions and percentage in what? Pharmaceutical calculation. Now let's look at this. There's a question here. If the adult dose of a medication is 2 teaspoonfuls, calculate the dose of a child if it is 1/4 of the what? Adult dose. Now let's go. We are told that the medication, the adult dose of the medication, they didn't mention the medication. They just said adult dose of a medication is what? Is what? Is what?
Is
2 what?
2
teaspoonful. They didn't mention the medication. They also said that the dose of a child dose of the same medication is what? 1/what? 4 of what? Adult what? Dose. They are not asking us to calculate the dose of the what? Child. Now, we are told that adult dose is 2 teaspoonfuls, but the child dose is 1/4 of the adult dose. We are given adult dose as what? 2 teaspoonfuls. So wherever we see adult dose, we replace it with what? 2 teaspoonfuls. Remember? Okay, we've not done it. We'll talk about it. There are these things, you may understand this when we do. By the time we are done with systems of measurements. Say we have this teaspoonful is equivalent to what? 5 ml. This 5 ml is metric system. This one is what? Imperial system. Under here we have the specifically avoirdupois. We'll still do it. Now we also have desert spoon, which is 10 ml. We have tablespoonful, which is 15 ml. Don't worry, we'll still do it. Let's continue. Now, anywhere we see adult dose, we replace it with what? 2 teaspoonfuls. So now that means child dose is equal to what? 1/what? 4 of what? Of what? 2 what? Teaspoonful. True of us? With that, remember with off now, we can replace off with what?
Times.
Multiplication, right?
Yes.
So that means the adult child dose is 1/4 times what? 2 what? Teaspoonful. Which is certain as what? What will go now? 2 will go here, 1, 2 go here. So we now have what? Half 1/2. 1/2 what? Teaspoonful, which is what? Half teaspoonful. So that means for the child dose is what? 1/2 teaspoonful. Have you now seen the application of fraction in pharmaceutical calculations? Now let's do another calculation. The second question I have here from the same reference book says that if a child dose of a cough syrup is 3/4 of teaspoonful, if a child dose of a cough syrup is 3/4 teaspoonfuls and represents 1/4 of the adult dose, calculate the corresponding adult dose. Now we are told here that the child dose of a cough syrup, they didn't mention the specific cough syrup, they just said cough syrup. The adult dose of the cough syrup is what? 3/4 teaspoons. That means adult dose is what? 3/4 of what? 3/4 what? Teaspoons, right? Huh? Okay, sorry, child dose, not adult dose. Child dose, sorry. Child dose is 3/4 what? Teaspoonful. We are told that the child dose is also, the same child dose is also what? Equal to what?
1 over 4.
1 over 4 of what?
Of adults.
Of what? Adult what? Dose. So we are now told to find what is the adult what? Dose. So what I'm going to do, since we have been given, we are told that child dose is 3 over 4 teaspoonful. So that means whenever we see child dose, we put what? 3 over 4 teaspoonfuls. So that means that here now, child dose is here, right?
Yeah.
Here is now equal to what? 3 over 4 teaspoonful is equal to what? 1 over 4 of what? Adult what? Dose. Remember, this is also the same thing as 3 over 4 what? Teaspoonful equal to what? 1 over 4 times what? Adult what? Dose. True of us?
True.
So with that now, we'll continue. It's equal to what? 3 over 4 T what? Is now equal to what? 1 times adult dose is adult dose. So we have what? Adult dose over what?
4.
Over what? 4. So what do we do here now? We cross multiply. True of us?
True.
So if you cross multiply, you now have that what happened? Adult dose times what?
4.
It's equal to what?
Is equal to 3 teaspoons
3 teaspoonfuls times what?
times 4 all over 4.
Times 4. Now, let me clean here. So making adult dose, sorry the formula now, we would divide both sides by what?
By
4. We now have that adult dose times what? 4 over what? 4. It's equal to what? 3 teaspoonfuls times what? 4 over what? 4. True of us?
True.
So 4 will cancel 4 here.
Yes.
4 here will do what?
Cancel.
That means adult dose is equal to what? 3 what? 3 teaspoonfuls. So the adult dose is what? 3 teaspoonfuls. Does it make sense?
Yes.
Okay. Thank you for watching our online lectures. For lecture updates, please subscribe to our YouTube channel. The name is Susan Limited. Just click on the red button and click on the bell by the side so that you'll be among the first people to receive notification whenever we upload a new video. Please like and follow us on Facebook. The name is Susan Limited. If you have any question, please connect with us on WhatsApp. These are our WhatsApp numbers. Please visit our website. The address is susanlimited.com. You have a lot to learn. Please share this video, like and comment. Thank you for your support. God bless you.
Admission. 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 Dear ladies and gentlemen, I bring good news. Admission into the diocese on the Niger School of Pharmacy Technician EENU Mission Hospital is on. The School of Pharmacy Technician (PhD) is an accredited tertiary institution that offers students a diploma degree to work in hospitals and pharmaceutical companies in order to promote safe and effective use of medicines at grassroots level. Graduates of Pharmacy Technician School EENU who wish to study pharmacy in the university can obtain direct entry into any university of their choice. The school has a well-equipped laboratory, comfortable hostel, and a healthy refectory. The requirements for admission are credit in English, mathematics, biology, chemistry and physics. In GCE, WAEC, NECO, NABTEB are not more than 2 sittings. The School of Pharmacy Technician (PhT) is located at ENU Mission Hospital, Agidi, Anambra State. For more information, call 0803 708 1512, 0813 868 2003, 0803 267 5322. Diocese on the Niger School of Pharmacy Technician. A tradition of excellence.